By 2025, the planet has entered a critical phase in the fight against climate change. Global temperatures are rising, extreme weather events are intensifying, and carbon dioxide levels have surpassed 420 parts per million. But amid this crisis, a powerful ally has emerged: artificial intelligence. From optimizing carbon capture systems to predicting climate risks, AI is reshaping how we combat emissions and build a sustainable future. Today, we explore how this technology is turning the tide. Carbon capture and storage, or CCS, is no longer a niche concept. It's a $50 billion industry, and AI is its secret weapon. Let's break down how. First, optimizing capture efficiency. AI algorithms analyze real-time data from sensors in power plants and factories, adjusting variables like temperature, pressure, and solvent flow to maximize carbon dioxide capture rate. For example, Patagonia, a flagship CCS project in Texas, uses AI to reduce energy consumption by 15%, cutting costs from $100 to $70 per ton of CO2. Machine learning models predict equipment failures, preventing downtime and ensuring continuous operation. Second, accelerating material discovery. Traditional methods take years to test new solvents or membranes for carbon dioxide absorption. AI-driven simulations, like those used by startups such as Inari and Ocell, screen millions of chemical combinations in just a few weeks. This has led to breakthroughs in amine-based solvents and metal organic frameworks, or MWEFs, boosting capture efficiency by 30%. Third, direct air capture innovation. Companies like Climeworks and Carbon Engineering are integrating AI to optimize DAC systems. AI predicts atmospheric carbon dioxide concentrations, adjusts fan speeds, and identifies optimal sites for DAC facilities. For instance, AI reduced the energy cost of Climeworks' Orca plant in Iceland by 20%, making it viable at $600 per ton. Capturing carbon dioxide is only half the battle. Safely transporting and storing it requires precision, and AI delivers. First, smart pipeline networks. AI maps the safest, shortest routes for carbon dioxide pipelines, avoiding seismic zones in populated areas. In Canada, AI reduced transport costs by 15% for the Alberta Carbon Trunk Line, saving $15 million annually. Second, leak detection and monitoring. Machine learning models analyze satellite imagery and seismic data to detect leaks in storage sites. Startups like Insight Terra use AI-powered drones to monitor underground reservoirs, ensuring 99% storage integrity. Third, predicting storage risks. AI evaluates geological data to predict long-term risks, such as carbon dioxide migration or caprock fractures. The University of Alberta's AI model, backed by $1.8 million in funding, simulate storage scenarios with 95% accuracy. Case Study 1, Patagonia, Texas. Patagonia, the world's largest post-combustion CCS project, captures 1.6 million tons of CO2 annually from a coal plant. By integrating AI, the system reduced solvent regeneration energy by 20% and lowered operational costs by $12 million per year. Reinforcement learning algorithms adjust process parameters in real time, achieving a 90% capture rate. Case Study 2, Microsoft Carbon Negative Pledge. Microsoft aims to be carbon negative by 2030. Its AI-driven platform, developed with partners like Terra and 1.5, tracks emissions across more than 100 supply chains and invests in DAC and biochar projects. In 2025, Microsoft signed a $500 million deal to remove 500,000 tons of CO2 using AI-optimized DAC. Case Study 3, Ocell's Digital Forest Twins. Munich-based Ocell uses AI to model forest ecosystems, predicting carbon sequestration potential and wildfire risks. Their platform, funded by 10 million euros in Series A, has increased reforestation efficiency by 35% in Brazil's Amazon. 1. AI's energy hunger. Training advanced AI models consumes massive energy. DeepSeek's new energy-efficient algorithms cut computing power by 90%. But data centers still rely on fossil fuels. Microsoft emissions have risen 30% since 2020 due to AI infrastructure. 2. Public skepticism. A 2024 study found that 60% of U.S. communities oppose local CCS projects, fearing health risks. Women and minority groups, wary of tampering with nature, demand transparent AI governance. 3. Data gaps and bias. AI models trained on incomplete data, may overlook risks in developing regions. For example, flood prediction tools perform poorly in Southeast Asia due to limited sensor networks. 1. Policy and investment. The EU's Carbon Border Adjustment Mechanism, or CBM, and U.S. DAC hubs, $3.5 billion funded, are driving AI CCS adoption. Private investors have poured $20 billion into ClimateTech AI startups 2023. 2. Next-gen technology. Bioenergy with CCS, or BCCS. AI optimizes biomass supply chains for projects like Sweden's hybrid, cutting steelmaking emissions by 90%. Nuclear-powered AI. Microsoft and Amazon are investing in small modular reactors, or SMRs, to power data centers sustainably. 3. A call for equity. AI must not widen the climate gap. Initiatives like the U.S. Japan Flood Resilience Project, $1 million NSF funded, use AI to protect vulnerable communities, proving technology can be both powerful and inclusive. AI is not a silver bullet, but it's a tool humanity can't afford to ignore. From capturing carbon to empowering communities, it's rewriting the rules of climate action. The question isn't whether AI can save the planet. It's whether we'll act fast enough to harness its full potential. The clock is ticking, but with innovation, collaboration, and courage, a sustainable future is within reach.